Hello to everybody again. Sorry it's been a long time since my last videos of my Schwarz RTB2004. Unfortunately I've had some health problems over the last couple of years, and YouTube videos were sort of just something that took by the wayside because of that. But I'm back now anyway to make a few more videos, and recently bought a new piece of equipment from R&S, which is the power supply you're looking at, which is an NGE100. It's a 2-channel power supply. I wanted a small power supply for my lab, either 2 or 3 channels. This one is the 2-channel variant. They also do the 3-channel variant, and it's a 33 watts per channel power supply up to 32 volts. It's got some very nice features actually, this power supply. Ultimately I wanted a very small dual channel at least power supply. I've got a lot of single channel power supplies, but I wanted a small dual channel one, and I'm limited for space. This has quite a few features on it, so not obviously the actual display on it is an LCD display with a colour display which shows both the voltage, the amps, the wattage. Also shows you some stats figures of your power min and max, your voltage min and max, and your current min and max on both channels. It also has quite a few other features, and I'm going to use it in this video actually to power an LED light, and then have a look at the signals that this LED light, it's a light that's either for a cupboard or a car. In actual fact I'm fitting it to my son's old Land Rover. He wanted more light in the back, but I just wanted to have a look at the signals that it put out, because it's a very cheap Chinese light and there doesn't seem to be any sort of noise suppression on the power supply side, and it works from 12 to 24 volts. So we'll have a look at that in a minute. But just a very brief look at this power supply. It has a variety of functions. It's a linear supply, but I think it uses both the switch mode and linear to get the size down, but it's actually a toroidal power transformer in it, so it's a fairly heavy unit. What it has got on it, which is rather nice, is it has some extra features on it. So you've got protection features such as over voltage protection and over power protection, and these can be set on each channel, which is rather nice. I'm going to go through a proper video just demonstrating this. You've also got a fuse facility, which is a sort of a short circuit facility which you can set on both channel 1 and channel 2, and it can be linked. So if you draw too much current on channel 1 and it blows the fuse internally, then it switches channel 2 off, and it can be set from 10 milliseconds up to I think 10 seconds for that, but we'll go through that when I do a video. The best feature on this, which I've used recently, is the arbitrary easy arb on it, which gives you basically you can do 100 steps of voltage, current, and the duration from 10 milliseconds up to 60 seconds, and you can either get it to repeat to the 100 continuously, or you can set a number of repetitions. So if I say easy arb repetition and I set 3, and then I set number of data points, i.e. the number of voltage settings, I've now got 3 voltage settings. So I could set, which I was doing the other day, 12 volts for this light, 16 volts and 24 volts, and I had it on an amp, and I was running it for 30 seconds on each, and it was stepping round, but I'll demonstrate that when I do a video just on this. Then you've also got easy ramp, which again is actually very nice, which allows the power supply to ramp up when you first switch it on. So if I just show you that, if I put enable there on channel 1, I'll do a quick demonstration, and I put say 5 seconds on that, so I'm dialing in 5.8 seconds say. If I now go back out, and I've enabled it on channel 1, if I now go back out into my main display, channel 1 select, and then output on, if you watch the voltage 12 volts 800 milliamps, it's white so it's not on. When I switch it on, you can see it ramping up, and that's going to take the 5.8 seconds that I set to ramp up. This is green because at the moment it's showing that this is in voltage mode, constant voltage. If it was red, it would be in constant current, and then when you go to white on the display, it's switched off. But I'm going to go through this power supply completely and what it can do, show the waveforms, etc. But that'll be a separate video because that video in itself is going to be quite a long one. In the moment I'm going to set this up as I've done here for 12 volts at 800 milliamps current limiting. I'm going to take off the ramping because I don't need the ramp on for the moment. So if I go over to here, sorry, go over to easy ramp. I was on the wrong one, sorry. See, it's not easy to do it from this angle that I'm looking at it. And then I go onto there and go disable. My easy ramp has now come off. It's got other features on this power supply, and again I'll show them. It's got things like Ethernet wireless LAN, which you have to put a code in for that. You've also got digital I/O, which is another code license, unfortunately, which I don't have at the moment, but I'm hoping I may buy that, which gives you the ability to set output, digital outputs at 5 volt TTL level, so you can do things from the power supply. You can set up quite a few options on that. If you go to digital, oh, of course it won't actually do it. I was going to try option K103 not installed. I was going to show you the options, but I can't actually because it's not installed. But it allows quite a few sophisticated options, which I'll explain when I go into the video just on this. But for now anyway, I'll show the next part, which is the setup of the light, and then we're going to have a look at that waveform on the RTB2004. Okay. Right, just to explain the setup now, over here we've got an LED light, which is a car one, or whatever you want to use it for, obviously 12 volt to 24 volt it runs from, going into a scope probe, which actually is not an RNS probe, it's actually a Keysight probe, just because I was doing some testings of the two scopes and I wanted to use the same probe, so it just happens that this one's been set up to use at the moment with the RNS RTB2004. Obviously the power supply, again I've set this for 12 volts at 0.8 of an amp, and this draws about 650 milliamps. I've also got it on easy ramp, so as we started, I think I put it on 1.5 seconds, you'll see that I'm on channel 1. I push the output button, and if you watch this, actually I'll clear the memory first of all, which will clear all the statistics here. If I now put the output on, and it says easy ramp, as I put the output on, you'll notice it ramps up and the light became brighter, obviously. We've got the output power here and we're showing wattage, so we're showing here 12 volts. It's running about 650. What is rather nice about this power supply, which I've noticed that a lot of my other power supplies, the update rate on this is very quick, as in the update rate of both the voltage, the wattage and the amperage. So you can see that flashing around because this varies a little bit, and I've seen this with a multimeter. It's not absolutely steady, so it's, you know, it's within a couple of 5 milliamps. It's going up and down a bit, possibly because of the heat as the LEDs heat up, I would imagine, but you can see that that's altering fairly quickly. You've also got your power maximum, which is 7.86 watts, so that was the peak, or that it peaked at. Voltage maximum 12.01 volts, and the current maximum when I first started it was 0.659 of an amp, so 659 milliamps, and those stats can be reset if I want. So if I hold this down, this button down, it says channel history deleted. Now it's giving me 646, so you can reset those stats at any point, and it's something I quite like actually on that. Let's take a closer look at that just so you can see that clearly. Right, I've zoomed in at the display now. I'm going to clear that, so I'm going to clear the channel history, and that's cleared now. So we've got 7.7 watts minimum, 7.72 max, voltage 11.98 to 12 volts, so it's within that range, and 0.641 to 0.644 amps. If I actually switch off the supply, goes back to my 12 volts at 800 milliamps. If I now clear the channel history, obviously this is slightly warmer now, so it's probably likely to draw less current, but if I now ramp it on again, it's showing easy ramp. If I now ramp that on by doing the output, you see that ramping up. And interestingly enough, when it first peaked, it obviously puts 0.652 to 652 milliamps and 7.75 watts, where at the moment we're running at 7.72 watts. So it's like a min-max on a multimeter effectively, and this will update all the time. So the min and the max will continually update. If you want to clear them, you just use this button and you can clear that history at any point. But it's rather nice to have a running statistics mode for both your power min-max, your voltage min-max and your current. It's in green at the moment because we are voltage limiting. If I do a current limit, so if I go on to current, channel 1 I should be on. If I now turn this down, this draws about 650, so if I go and limit this to 500 say, Actually, it's already gone in, so let's say 590, 600. You'll now see that this has now gone on to red. So this is telling me that we're limiting at 600 milliamps, and it's 11.2 volts because it can't take the 12 volts because we're current limiting. If I go back to that again and go to current again, I can now do this automatically while I'm adjusting it live. It's just gone green, so we're now over 690, so we're now in voltage, constant voltage. If I drop that down, we're now in constant current. So you can do live adjustments, and I can do my live adjustments on my voltage as well. So I will go through a full demonstration of this. Let me just, sorry, it resets itself after you things. If I go back to say an amp, if I put that onto an amp, that's my set current, but as I set it, it'll drop back down showing me it's 12 volts and it's drawing 640 milliamps. If I switch it off, it goes straight to the set, which is 12 volts at 1 amp, which again is nice. So it always shows you your set, but when you switch it on, you then instantly know whether your voltage in constant voltage or constant current, because green is constant voltage, red is constant current. So we're using their constant voltage. Anyway, we'll now go and have a look at the waveforms on the RTB2004. So the scope probe is just wired up directly across the power feed to this light, which is just purely a 12 to 24 volt, and it's got a constant current driver in the light, LEDs, and then I think there's something like 30 LEDs on this. Fun enough, on Amazon, where this came from, they say that this is a 12 watt light, and somebody else had commented in the comments that it was only about 8 watts, and we're only drawing 8 watts, and if we put the voltage up to 24 volts, just as an instance, it doesn't actually rise, so it's still being limited. 24 volts, we're obviously only drawing 0.3 amps now, so 307 milliamps, but we're still getting 7.737 watts. If I clear that, and now if we ramp it on again to 24 volts, so I'm limiting at 24 volts, 1 amp. Let's do a limit, and that's a ramp. We can now see that we drew 585 was the maximum within that period, and the voltage maximum is 24 volts, and the wattage maximum was 7.6, but it's obviously got a current limit driver on this that also limits between 12 and 24 volts, so you can put anything from 12 to 24 volts into this light. But let's have a look at the waveforms now at 12 volts. So if I want to do that, I'll just put voltage back down to 12 volts. Obviously my current's going to go up because we're constant power, so voltage down, current up, because it's constant current driver and constant power. So we're set down to approximately 12 volts. Okay, and let's switch that off for the moment while I set up the waveforms. Right, we're now looking at the screen of the RTB2004. This is a signal that's coming off just where we're feeding the power into the light, and we're feeding it 12 volts, and it's drawing about 600 milliamps. We can see the signal on here, and in actual fact the frequency of this signal is 22 kilohertz, which I believe is the frequency of the constant current driver. And in actual fact, if you put this up to 24 volts, it goes up to about 80 kilohertz. So it's obviously varying, pulse width modulating to vary for the voltage. We've got a signal here of voltage peak to peak of about voltage peak to peak of 700 millivolts. The plus peak is about 500 positive, and the minus peak is about 213 millivolts negative. It's moving around a bit. If we zoom in on that, we can see the shape of the pulse, and in actual fact this is being done on average. If I actually go out of average mode and I go into peak detect, which I was showing something a little more interesting, if I then zoom in onto that, it's showing also that there is some high frequency switching noise that's coming through here. Ignore that, it's slightly having trouble triggering, which is not surprising. That's better triggering, better there. So I'm now triggering just on the top. You can see here that again we've got about 874 now peak to peak, because we've got the spike. Bottom is about the same. What I did find nice on this scope actually, and it's one, the screen is just so large compared to my Keysight, but I also quite like the different colour modes on this that the Keysight lacks, so that if I go to Waveform Colour and I go to Fire, I often use the Fire mode because the Fire mode now is showing me the red is the constant signal, which is occurring more often. The yellow is the less frequently occurring, so you can see the noise is in yellow, so the high frequency noise on the edge of the signal is in yellow, and the red is the main pulse. If I zoom in on that, you can now see, I can move that with my hand as well. I also find with this scope that the touch controls are very fluid. Some people criticise it for being slow or laggy. I've never found that. I mean, that to me is not laggy, and if I move it that way it's not laggy. I find it's very responsive. So that's now showing again. If I want to switch off the colour, what's also nice in one of the latest firmware updates is this ability to bring items out onto the screen, and this was one of the later firmwares. I will go through all the differences in another video, but for the moment I've brought out that waveform colour there now, so I can now bring that option out here. If I touch that now, I can now adjust it on the screen, so that's the default. If I want to go and see my Fire representation, I don't have to go into the full menu, otherwise you're going to go into the full menu, then go into it here, waveform colour, and it becomes a bit long-winded. Actually, I use my mouse, it just make it easier to show instead of sticking my finger in the way all the time. But it's the same, you can bring out any of these. So if I want to bring out invert, I've brought it out to here, so I can stack these if I want to put that over here, and if I want to invert that signal, just say, I can just click on my, let's bring that down a bit so we can see the whole thing again. Just bring the voltage down. I've got that in fine adjust, but just to show you what I mean with that now, and this was one of the later firmware adjusts, was the ability to bring out these sub-menu parts, which I think was on the RTM scope, and then they brought it onto this, and it's a great feature because now you can literally bring out any additional sub-menu you can bring out. I can also move the waveform with my mouse pointer, and I'm just using a standard cheap mouse, Belkin cheap mouse, which I always use when I'm driving this scope. I just find it easier, and you can alter it on many things. So for instance, if I want to alter the time base, I can just click on the mouse. I can also use the mouse scroll wheel on a lot of settings, which is actually quite useful. What they've also done, and I'm going to go back into doing some reviews of this scope, they've also brought a lot more features in terms of the maths menus, which are now fantastic. So whereas they were a bit limiting before, if I go to maths over here, I'm having a blank spot at the moment as to where my maths are. No, it's not measure, it's maths, sorry. Having a senior moment. When I go to maths menu now, ignore I've got some set up here already, but basically now you've got 5 maths channels. You can do maths upon maths, and you can also now, instead of just having plus minus, division and multiplication, which the original firmware had, that was incredibly limiting and was really my major complaint about the scope, they've now got the standard. Then you've got square, square root, ABS value for your absolute values, your reciprocals, your inverse, your common log, your natural log, your derivative, and your integral, which actually is the area under a curve, which is fantastic if you want to work out power. And I've used that when I was working out some power calculations, using the integral to get the area under the curve, using a current clamp, and I will show that at some point in a future video. But you can also name your units, and you've got loads of choices here now. So in your maths formulas, your volt, amps, ohms, S, volt amp, watts, volt amps, VAR, VS, VPP, dBm, you can name it whatever, and I think there's also a way of naming it whatever you want to yourself. So I think there is, I don't know if that one is the one where you can name it yourself. No, maybe I'm wrong on that. I thought you could actually name it yourself, but maybe you can't. But you have got a lot of different options here now, so you can name whatever you want, and you can do maths upon maths. So if you've got your first maths, which here is channel 1 multiplied by a constant 15,000, because I've got 15k in there. I think I was doing something with a resistor and working out current. But you can then bring in your result of your Maths 1 channel. So on my Maths 2 channel, I can actually select Maths 1. So I can do maths upon maths, which really makes the system extremely powerful when you can do that. But I'll go into a video on that. It's not really appropriate with what we're looking at here, but it's just interesting. Now I've got obviously maths switched on now, but if I switch my maths off for the moment, and if we go back and look at that again, what we've also got on this is, as I said to you, the different waveform colours, which allow different features to be shown, and in actual fact the scope will tell you what those are, as in if that's on rainbow, fire or temperature. If I go to rainbow and I want to know what rainbow does, I can actually get a help menu out. So if I go to help, I need to first of all, need to go into my menu where my colours are, so if I go into rainbow here and then do help, it will now tell me my different features. So my rainbow display in a rainbow colours, blue corresponds to rare occurrence of the samples, while red indicates frequent ones. Temperature displays in temperature colours, blue corresponds to rare occurrences of the samples, while white indicates frequent. I tend to use fire quite a lot, which is the one we've got on, I think. Displays in fire, yellow corresponds to rare occurrences of the samples, while red indicates the frequent ones. So if I'm looking at this now, take that out again. Sorry, let's use the mouse, it'll be easier. I'm actually now on rainbow, but if I go from that to fire, which I tend to use, then that's showing me now which ones are more, which ones are rarer, and which ones are more occurrences of. So the red waveform in the centre is the standard waveform, and the yellow, the noise you can see in the spikes, they're all the less rare occurrences. In actual fact, if I get rid of peak detect and just go to sample, high res, you can now see that that high res is filtering out the less common ones. So the yellow is now is virtually gone there. But this doesn't, my Keysight doesn't have this ability. It has the grayscale on it, actually not grayscale, I'm not sure what they call it. It has the ability to alter the waveform like this, so that I can actually alter the strength of the waveform, but it just doesn't give me the same as this. I just find on this, and this is a classic example where if I'm here, I go into my acquisition of peak detect, it just gives me a lot more information, particularly when you zoom in. You can see the yellow are the rare occurrences, so they're obviously high frequency spikes, and the standard one, the red. But anyway, that's just a short video, which actually turned out not to be so short, just as an introduction back, now that I'm doing some videos again. The next thing that I'm planning to do a video on the scope is Bode plot, because this has the Bode facility. So if I go into the menu, there's a Bode plot facility on this scope, which is rather nice, and I'm going to demonstrate this Bode plot facility using a Cypress development kit that allows me to produce different bandpass filters, all in an IC, all in an FPGA or microcontroller stroke FPGA. But that will be another video which hopefully I'll post in the next couple of weeks, once I get myself back up to doing videos again. And this introduction one was just to get myself really back into making videos again. I hope it wasn't too long, and I hope people have enjoyed it. If anybody would like to see anything specific on the scope that I'm able to do, that I have the equipment to do, please post it in the comments, and I'll be very happy to try and do that. I'm also answering any questions that people put up on the comments. Just give me a week or so if you do post a comment, and I will try and keep up to date with answering comments. Anyway, I hope you've enjoyed that, and we will hopefully see you again shortly. Stay safe. I hope everybody is well, or as well as they can be at the moment with this COVID terrible situation. But for the moment, well, I'll see you again hopefully in the next couple of weeks. And for the moment, stay safe, and hope you've enjoyed this video. Thanks. Bye.